Hey, algebra students, in this lesson, we are going to be looking at two-step and multi-step inequalities. So these are inequality expressions, and the same rules apply that have always applied. The inequality symbol is going to keep the same exact shape unless we are going to be multiplying or dividing by a negative number, in which case the inequality is going to flip. And that's the only thing that can happen to the inequality. It's either going to flip from one side to the other or it's going to remain the same. So we're going to work some practice problems and see how that plays out in some real problems. The first thing I'm going to do is I am going to start by answering question A. We have 4x plus 29 is less than or equal to 25. Let's see if I can grab a less than or equal to sign. All right. And there it is. Okay, so we're going to use that. And then we know it's less than or equal to 25. Now, how are we going to solve this? Well, I need to get, okay, so this is a multi-step problem. I need to get x on a side by itself. The first thing I'm going to do is subtract 29 from both sides. That's going to give me 4x is less than or equal to negative 4. I have negative 4 on the right, but I'm not actually going to divide or multiply by negative 4. I'm going to divide both sides by 4. I'm going to divide both sides by 4 to get x by itself. I'll be left with x is less than or equal to negative 1, and I've solved my inequality. Now I need to graph that solution. I'm going to show you what the graph to the solution looks like. Here's negative 1 on a number line. You see where 0 is on that number line. I've filled in the circle because it's less than or equal to, so negative 1 is a solution, and shaded everything to the left. All right, that's how you do letter A. Let's move on to letter B. We're going to work this one much the same way. Negative 36 minus 7k is less than 6. First thing I'm going to do is add 36 to both sides to get k, the k term on a side by itself. That's going to give me negative 7k is less than 42. Now I need to divide both sides by negative 7, and that should be setting off alarm bells for you, because when I divide by a negative, what that means is I'm going to have to flip my sign. So this is going to be x is greater than negative 6. All right, let's just check our answer and look at what the graph looks like here. So, and it's k because I used the wrong variable. I switched to x down here, but it should have been k. There we go. K is greater than negative 6. All right, so that is the correct answer. Notice it's not a filled in circle, and it's an empty circle because negative 6 is not a solution, but we're going to shade everything to the right of negative 6, and that is correct. Now, let's just make sure that I got this right. 0 is one of the shaded things in this solution set. What if I plug in 0 for k? Is it a true statement? Negative 36 minus 0, so just negative 36, is less than 6? Yes, that was correct. What if I plug in negative 6? Is negative 6 going to be an equivalence, which is not a solution? So negative 36 minus 7 times negative 6, so plus 42. Negative 36 plus 42 is 6. Is 6 less than 6? No. So this is the correct graph. I've just verified it by testing a few points, including the point on the circle. All right, let's go on to letter C. We're going to actually move our work down. Okay. All right, so for letter C, we have negative 18 plus negative 3. Well, let's see. Negative 18 plus negative 3 is just negative 21. Okay, so I'm going to simplify on the left-hand side here first and just add those negatives together. Is less than negative 4f plus 11. Next thing I'm going to do to solve this is I'm going to subtract 11 from both sides to get the f term on a side by itself. I'm not going to flip the sign because I'm just subtracting 11. So this is going to be negative 32 is less than negative 4f. But this next step, I need to divide by a negative 4. Anytime I divide or multiply by a negative, the sign flips. So this is going to be 8 is greater than f. And if I want to write this so that f is on the left-hand side, if I switch sides of everything in the inequality, I also flip the side. So it's going to be f is less than 8. I flip the sides of everything in the inequality to do that. All right, so f is less than 8. Let's just see if that works. So I'm going to plug in 0 again because 0 is less than 8. Let's see if 0 is a solution to this. So if I plug in 0, I have 11 on this side. Negative 21 is less than 11. It works. So that's evidence that I did this correctly. This is what the number line looks like. Open circle at 8, shade to the left. All right, letter D. In letter D, we have negative 5 times 10 minus 5p. I'm going to distribute that right away. This is going to become negative 50 minus, minus a negative 25p. Minus a negative is going to become a plus 25p. Okay, do you see what I did? I just distributed this negative 5 into a 10 and negative 5 to the negative 5p. So I get negative 50 plus 25p is greater than negative 10 squared. Okay, notice my negative is in parentheses. So this is actually negative 10 times negative 10. If the negative was outside the parentheses, it'd be a different story. Because the negative's in parentheses, this is going to be 100, positive 100 on the right-hand side. Now remember, if the negative is out in front of parentheses, you do the square first, and then you apply the negative. All right, let's solve this. First thing I'm going to do is add 50 to both sides. That's going to give me 25p is greater than 150. Now I'm going to divide by 25 because I'm not dividing by a negative. I don't touch the sign. This is going to be p is greater than, let's see, 25. If you ever run into this problem and ask yourself, how many quarters does it take to make $1.50? 6 is the answer. P is greater than 6. Let's see if we did that one right. There it is. Open circle at 6, shade to the right. Hey, what if I plug in 6 to this one? Let's see what happens. 10 minus 5 times 6. Well, 5 times 6 is 30. 10 minus 30 is negative 20. Negative 5 times negative 20 is 100. Is 100 greater than 100? No. It's the same. So there would be my open circle at 6. And then I'm going to shade to the right of it. All right, letter E. Our book has a very specific recommendation for what to do with ones like letter E, where I have fractions that complicate things. Now, the first thing I'm going to do is I'm just going to go and grab the greater than or equal to sign. We've been using less than or equal to. There we go. Okay. So now, our statement is 1 over 12 y plus 2/3 is greater than or equal to 5 over 6. Now, I'll tell you, I can solve this equation just like it is by subtracting 2/3 from both sides, but it is going to be a pain in the beehive to try to work with these fractions. Is there a way, if only there was a way for me to get rid of these fractions? Well, here's what I can do. I can look at my denominators of all of my fractions and find the least common multiple and multiply everything by the least common multiple. And what that'll do is it'll get rid of my fractions. Let's just see what we can do with this. So 12 is made up of the factors 2 times 2 times 3. 3 is just made up of the factor 3. Okay, so I use 12 because that's my denominator in my first term. 3 is my denominator in my second term. And my denominator in my third term is 6. 6 is just 2 times 3. What is the least common multiple of these denominators? Well, as I look, I see that the most number of 2's I have in any of these is 2. 2 times 2. And the most number of threes I have is 1 in each. So 2 times 2 times 3. Why, that's just 12. 12 is the least common multiple of these three numbers. What I'm going to do is I'm going to take all three numbers in this inequality statement and multiply each term by 12. What am I going to get after I multiply each term by 12? Well, 12 times 1/12 y is just y. The 1/12 cancels out the 12. Plus, 12 times 2/3 is 24/3, which is 8. Y plus 8 is greater than or equal to. And then 12 times 5/6 is 10. 12 times 5 is 60. 60 divided by 6 is 10. So I get y plus 8 is greater than or equal to 10. And that is easy to solve because I just subtract 8 from both sides. I get y is greater than or equal to 2. Let's make sure I did that right. Do you see how multiplying every term in a fractional inequality by the least common multiple of the denominators makes this really easy to work? I could have dealt with the fractions, but it's much easier to deal with if I get rid of the fractions. All right, and then letter F. A student runs a quarter mile in 180 seconds. She improves her time by 5 seconds each week. To find the number of weeks needed for her time to be at most 150 seconds, solve the inequality. 180 is the amount of time she's running it in now, minus 5 times t, because each week she beats her time by 5 seconds, is less than or equal to 150. Now, I realize there's a mistake in this problem. This should be 5w, so it's times the number of weeks. So here's what it should be. 180 minus 5w is less than or equal to, let me just grab this symbol from up here, less than or equal to 150. I think we need to figure out what number of weeks makes this true. First thing I'm going to do is subtract 180 from both sides. That's going to give me negative 5w is less than or equal to negative 30. Now I'm going to divide both sides by negative 5. Well, there I'm doing it. I'm dividing both sides by a negative. That means that I'm going to flip the sign, and this is going to become w is, and let me just grab this sign from up here, greater than or equal to, and then negative 30 divided by negative 5 is 6. So it's going to take more than 6 weeks, or exactly 6 weeks, for her time to be at most 150 seconds. If she goes more than 6 weeks, her time should be less than 150 seconds. And that is how we solve that inequality. So now you know what you're doing. You can solve these sorts of problems. You're ready to work numbers 1 through 30 for next time.